Ich sehe nicht. Aha, er rumpelt. Schießt.
Schau dir mal diese Fahne an. Oh, das ist ja unten.
Jetzt fängt der untere Lavastrom auch an. Schön.
Ja, wenn alles. Jetzt kommt der.
haben wir ein fantastisches, das Echo drüben. Echo, Mensch. Mal die Bäumchen an, die da runterkommen.
More tsunamis in the Pacific Ocean than any other. So in 2004, the world was taken by surprise when one of the largest recorded tsunamis of all time took place in the Indian Ocean. On December 26, 2004, Indonesia was rocked by the second largest recorded earthquake ever, 9.2 on the Richter scale. Minutes later, a 90-foot tsunami slammed into the Southeast Asian coastline. 225,000 men, women, and children lost their lives.
The Indonesian earthquake had as much energy in it as the total energy consumption in the United States in 1 year.
This enormous burst of energy had been released in just seconds. Once again, the world had been reminded of the Earth's awesome power. In the last 50 years, scientists were finally able to confirm a solid link between earthquakes and tsunamis. Although the Earth may seem to be a solid sphere, beneath the oceans and continents, it is divided into 8 major and many minor segments known as tectonic plates. Where they meet, they can grind and jostle against each other at fault lines, causing earthquakes. Geologists had long thought that the Cascadia fault line was incapable of generating a major quake. But Atwater's investigation has proved that it was highly active. The big worry for Atwater and the thousands of people who live in this region is that the Cascadia fault line bears an uncanny resemblance to another highly active fault line, the Sunda megathrust. It was an earthquake along this fault that was responsible for the Indian Ocean tsunami that killed nearly 250,000 people.
Where we get two tectonic plates coming together, such as in the case of the Indonesian tsunami in 2004, one plate pushes beneath the other plate and creates lots and lots of friction and tension and drags the upper plate down with it. And that process can take hundreds of years, even thousands of years. It's a very slow process. But eventually, the pressure of this one trying to push back up again wins, and it flips like that. And that creates a megathrust, a sudden movement of the seabed. And that's what creates a phenomenal tsunami.
It happens because hot rock rises, heated by the Earth's core. Near the surface, the rock spreads in two directions and goes sideways. It begins to lose heat. Eventually, the much cooler rock sinks back down. Through this spreading process, the Earth's crust is very slowly dragged apart, and it's this that ultimately causes the continents to move. Where the plates collide, the rock on the seafloor containing carbon from the dead plankton is carried deep into the Earth. As it descends, this layer of rock is heated, so the rock melts, releasing carbon dioxide. And gas is returned back into the atmosphere during an eruption. The remarkable cycle
Earth
is
scientists
complete.
theorized that 200 million years ago, the continents formed part of a single giant landmass called Pangaea. Pangaea split into two land masses called Gondwanaland and Laurasia. Over time, Gondwanaland broke apart, forming the continents of South America, Africa, the Indian subcontinent, Australia, and Antarctica. Laurasia split into North America and Eurasia. The movement of the continents to their present positions took place over millions of years. Earth scientists believe the continents will continue to drift and change their shape. It is possible that 50 million years from now, the Earth's continents will look like this.
my God! Did you see that? The whole house